students, I wanted to take the time to review with you today factoring because it is probably one of the most important Algebra 2 concepts that you are going to learn this year. We use it throughout the rest of Algebra 2, and you will use it next year in pre-cal. You're going to use it in calculus. So it's really important that we get a solid grasp of factoring. So I want to review this with you, and you make sure and practice. Factoring is one of those skills that just takes practice. There's no other way to be able to capture this skill. So be sure that you practice all of the practice problems, and if you need more, Google it. Get more practice, but just make sure you feel confident in factoring before you leave these lessons. Okay, with that said, I made some notes, so if you printed out the notes, you can follow along with them that way, or you could just follow along on a scratch piece of paper, but be sure you're not just watching this video. Pause it and work the examples with me because it's really going to help you understand it better. Okay, so first let's review what we talked about last class with factoring out. First, we always look for a GCF, a greatest common factor. So be sure before you begin any factoring problem, you are always looking for that greatest common factor. So on this one, what I'm looking for is what can I divide into both of these? Well, both of the numbers are divisible by 3, and they both at least have one x, and they both have at least a y squared. So I could divide both of these by 3xy squared. So when I divide 6 by 3, I'm left with 2. X squared divided by x is just x. Y cubed divided by y squared, and I'm left with y. All right, negative 9 divided by 3 is going to be negative 3. X divided by x is 1, so we don't need to write that. That cancels out. Y squared divided by y squared is also 1. Okay. Now to check to make sure that we have factored it correctly, we could distribute and multiply it out, and it should equal our original problem. So that's one way to verify, to make sure that you factored it correctly. We're kind of like undistributing when we're factoring. So when I multiply 3x squared times 2xy, I get 6x squared y cubed. That checks out. Now I'm going to distribute here. 3 times negative 3 is negative 9xy squared. So these are our factors. Okay, these are the factors. We're not going to get solutions on this one because it's not equal to y or equal to 0. And so this one we really are just going to focus on getting the factors. And we would look to see if we could factor any of our factors further, and we can't. But we always ask the question. Okay, look at example 2. So remember, we always look for that GCF first. Do we have something we can divide all of these by? There's not in this case, okay? But we always check. And then second, we look to see if we can factor further. Well, in this scenario, you have the choice. Remember, I taught you in the previous lesson, you can either use your Xbox method or the grouping method. Those were the two methods we learned. I told you choose one. Choose one that you feel more comfortable with. A lot of students who got confident with factoring in Algebra 1 are more comfortable with grouping, I have found. And students who didn't really understand it in Algebra 1, it didn't stick with them, they tend to like the Xbox. But it's really up to you. Whichever one makes the most sense to you is the one I want you to do, because I want this to be a process that you understand and that you can do successfully over and over and over again. So I'm going to do one example Xbox, one grouping, so that everybody here is hopefully caught up to the same page. All right, so for the Xbox, we always start with our x. We need to brainstorm two numbers that multiply up to negative 24 and add up to negative 10. So we need factors of negative 24 first. So what are some numbers that multiply up to 24? So let's just brainstorm. 1 and 24, 2 and 12. Pause the video and see if you can find those numbers, and I'll catch up to you in a minute. Okay, I hope you have brainstormed all your numbers. This is a really good example because a lot of students want to choose 6 and 4. Negative 6 and negative 4 do add up to negative 10. But what's wrong with that answer? Problem is, negative 6 and negative 4 would multiply to a positive 24, not negative. So this answer does not work. So go back to your brainstorm and see what other options you have. Well, notice if I choose 2 and 12, I could do a negative 12 and a positive 2. That would add to negative 10 also, and it would multiply to negative 24. There will always be one correct answer, so you need to fully brainstorm to make sure you found the right pairs for your answer. Okay, so now we have our two magic numbers. We are ready to plug them into the box. The first term always goes in the first box. Last term goes in the last box. We are splitting the negative 10x into 2x and negative 12x. We are dividing those two terms up. So they will always have this term with it. So negative 12x and 2x that we brainstormed from the x. Okay, we are looking for the GCF across these rows. So the GCF of this row would be x. The GCF of this row would be x. So x times x is x squared. X times what gives me negative 12x? That's negative 12. X times what gives me 2x? 2. And 2 times negative 12 is negative 24. So it checks out. So these multiply out to be everything inside the box. So my factors are x minus 12 and x plus 2. And if we set these equal to 0, we can find our solutions. If I set this equal to 0, x will be 12. And if I set this equal to 0 and solve, x will be equal to negative 2. So those would be our two solutions. All right, last example. I would like you to pause the video and work this one fully on your own. If you would like to see a grouping example, I will do a grouping example now. Before you start factoring this one, I want you to notice one thing. Notice this 12 is on the wrong side of the equal sign. We cannot begin factoring until it is equal to 0 because then the 0 product property will not apply. So be sure you get everything to one side of the equal sign. You set it equal to 0 in order to find your solutions or roots or zeros or x-intercepts. Remember, those 4 names mean the same thing. So before you begin factoring, I'm going to subtract the 12 to get it over to the correct side of the equation. And now you may begin to factor. Okay, I have brainstormed my numbers. I came up with the two factors of 3 times negative 8 is negative 24. And they also sum to be negative 5. So now we're going to do the grouping method this time. If you're comfortable with the X box, go ahead and do that. Okay, so those of you that like grouping, we are going to bring the first term down. We are going to split the negative 5 into the two factors we just brainstormed, a negative 8x plus a 3x. Notice they add up to the negative 5x. Bring down the negative 12. Okay, now I'm going to look for a GCF of the first two terms, and both of those are divisible by a 2x. And so 2x squared divided by 2x is x. Negative 8x divided by 2x is negative 4. Now I'm looking for the GCF of the second two terms, which would be a 3. 3x divided by 3 is x. Negative 12 divided by 3 is negative 4. Okay, so notice both of them have a matching factor of x minus 4. So I can kind of factor out the x minus 4. So when I factor out an x minus 4 out of these two terms, I am left with, so I factored this out, and I'm left with 2x plus 3. Because when I divide this term by x minus 4, I'm left with 2x. When I divide this term by x minus 4, I'm left with a 3. So now I have my two factors. And if you did the X box, you should have gotten the same factors that we did. Now, so these are the factors. Remember, factors are what are in parentheses. Factors mean something that multiplies up. So these two things multiply to get our original problem. That's what a factor is, things that multiply. Notice these were the factors of 24. Keep in mind what those words mean. They're very important math. So the solutions would be when we set each of our factors equal to 0. So if I set x minus 4 equal to 0 and solve, I'll add 0 to both sides, and I'll get 4 for this factor. And when I set this factor equal to 0, I'll subtract 3 and divide by 2 to get negative 3/2. Okay, so that's a review of what we did last class. Now we're going to dive into factoring a special case called the difference of squares. It's a special pattern that's actually a huge shortcut if you know it. What I want you to do, first of all, before we look at the steps, I want you to look at the problems. Look at the first row of problems, and what do you notice? I'm hoping one thing you notice is that they all have a minus sign between them. And another thing I'm hoping that you notice is that they are all perfect squares. What I mean by that is when I take the square root of it, it comes out to a nice whole number. So like when I take the square root of 36, I get 6. When I take the square root of 144, I get 12. When I take the square root of 25, I get 5. When I take the square root of x squared, I get x. Yeah, I get x. So all of these are actually perfect squares. So there's a special pattern with factoring that works out really nicely if both of the terms are perfect squares and it is being subtracted. If that is the case, then the pattern that you can follow for the factors is you can take the square root of both terms. So if I take the square root of that, it's x and x. The square root of 36 is 6 and 6. One's going to be a plus and one's going to be minus for the two sets of parentheses. Now really, we're doing the same thing as we were doing up here. This is just a shortcut pattern if it is the difference of squares. It's going to save you a lot of time, and it makes some of them that are really hard actually easy problems to do. So it's a good pattern to be aware of. Notice if I multiplied this out, x times x is x squared, 6 times 6 is negative 36. This would be a positive 6x and a negative 6x. That would cancel out. 6x and negative 6 is 0. That's why there's no middle term here, okay? So that's why this pattern always works, only if they are subtracting. So that's the pattern you're going to look for in these. So what I would like you to do right now is pause the video and try the next two problems on your own and see if you can figure out what they would be. Factors, just the factors. Did you get it? On the first one, you should have gotten x plus 12 and x minus 12. Remember, it doesn't matter which order they're in. So if you did x minus 12 first, that's perfectly acceptable because remember, 3 times 4 is the same as 4 times 3. We can multiply in any order. They're both acceptable. So if we wanted to get our solutions here, and I set these equal to 0, you should get negative 12 and positive 12 would be our two solutions. Same with this one. We should get minus 5 and divide by 2, so it should be plus or minus 5/2 for this one. When I take the square root of 4x, you get 2x. So check your 2x there. You don't have just an x. It should be a 2x. Okay, down here it gets a little trickier, so let's just do a couple of these. The pattern is still exactly the same, though. Take the square root of 16, that's 4. The square root of 81x is 9x. And one's a plus, one's a minus. Students tend to want to switch these around and do 9x plus 4. The problem is this negative sign goes with the 9x, so just leave it like this. Resist that temptation to switch it around. I know it's super common in algebra for always to put the x term first, but in this case it would mean something else, so don't do that. Just leave it like this. All right, so take, now notice these are not perfect squares. But what did we forget to do? We always look for what first before we do any kind of factoring problem. We always look for the GCF. So what is a number that I could divide into both of them is what you need to be thinking of first. The largest number that you could divide into both of them. And then see if you can factor further. So pause the video and I want you to think about that for just a minute. So the largest number that divides into both of them is 2. So after you divide 2 out of both of them, you're left with this, which now these are perfect squares. 9 and 16 are both perfect squares, and x to the 4th is a perfect square as well. Also, because x squared times x squared is also x to the 4th. So we're going to bring our GCF down, and we're going to square root both of these. Square root 16 is 4. 1's plus, 1's minus. Okay, last example, look for a GCF, and then see if you can factor it further. So there happened to be no GCF on this problem, but they were both perfect squares, so you should be able to factor them using the difference of squares pattern. Okay, let's try a couple word problems before we close today. I know word problems are always scary, but they don't have to be. You can just walk your way through them mathematically, and the more you practice, the easier they become, and the more you get used to those kinds of problems. So in example 1, we have a Jose who purchased carpet to cover the floor of a rectangular room that has an area of 96 feet squared. So that's the area. The width of the room he is carpeting is 4 feet less than the length. So we're talking about the width. So the width equals 4 feet less than the length. 4 feet less than the length. So if we take the length and we subtract 4 from it, we should have the width. Right? That's what it's saying there. The width of the room he's carpeting is 4 feet less than the length. So if we knew how long the carpet was, the length, we could subtract 4 and we would know what the width was. All right, so to find the length and the width, we need to know the formula for area of a rectangle. Well, area of a rectangle is just length times width, or sometimes people say base times height, but we have a length and we have a width in this problem. So if we're going to multiply the length times the width, we're going to get the area. Oh my goodness, look, they even gave us this little cheat right here. I didn't even notice that. So area is going to equal, this is what is going to represent our width. So I'm going to plug this in for the width. Oh, that should be a 4. Length minus 4. And now we have an equation that we can solve because we know the area is 96 feet squared. They gave that to us. So now we have the area equals length times the width. And we only have one variable. We only have L. So we should be able to solve it now. Now, this is not anything we can solve yet. We need to get it in a form that we can factor it in. So I'm going to go ahead and distribute this. 4L. And remember I told you that it has to be equal to 0 in order to factor it. So I need to get this equal to 0. So L squared minus 4L minus 96. If I subtract this positive 96, now it's equal to 0. Okay, this is a little challenging factor problem. So I want you to pause the video and see if you can factor this on your own. Go for it. Okay, so for your factors, you should have got L minus 12 and L plus 8. So L is 12 or negative 8 if we find the solutions. Now, it makes no sense to have a length of a carpet of negative 8. So we're going to cancel that out. It doesn't make any sense. So that means the length of our carpet is 12. And if we know that our width is 4 less than the length, we know our width of our carpet is going to be 8. Okay, keeping that in mind, I would like you to try example 2 on your own. See if you can write an equation like we did here. Or you can write it in this form. Either way, get an equation, and then see if you can solve to find the dimensions of the rectangle. Pause the video here and give it a try. All right, for your equation, you should have gotten the area is 91. The width, they said, the length is 6 inches more than the width. Length is means equals, 6 more than the width. So that's what you're going to plug in for length. And you'll leave the width as the width. So we're solving for width this time, the W. So distribute, get it equal to 0 so that you can factor it. Once you factor it, you should get solutions of 7 and negative 13. Remember, we cannot have a negative width, so we throw that answer out. Therefore, our width is going to be 7 inches. And our length, we learned, was going to be 6 more. So that leaves us with 13 inches. Okay, final question on our practice notes today is to do this challenge factor. And I would like you to try it on your own. Don't be scared that there is something to the fourth power here, because you can factor this trinomial just like you've been doing all along. Either use your X box or your grouping. I would like you to try this last challenge on your own. Okay, so you should have noticed that you needed to brainstorm numbers that multiply to negative 18, factors of negative 18, and it needs to sum to positive 3. So I brainstormed and I came up with 6 and negative 3 as my two factors. So I put the first term into the first box, last term into the last box, and then I took the 3x squared and split it into 6x squared and negative 3x squared from my brainstorm here to put it. Remember, it doesn't matter which corner you put those in as long as you get them in the two corner boxes. Okay, so I'm looking for the GCF. The GCF of here is x squared because I could divide x squared into both of those. I also could divide x squared into both of those, which works out great because x squared times x squared is x to the fourth, which is what we were shooting for. X squared times what is negative 3x squared? That should be negative 3. X squared times what is 6x squared? That's just 6. 6 times negative 3 is negative 18. So our factors are x squared plus 6 from here and x squared minus 3. I hope you got it. If you did, you are now a factor master, but I want you to keep practicing to make sure you got it down so when you get to this test, you feel like you can conquer it. Great work today, guys.